My esteemed viewers, today we are going to be looking at the concept of chemical equations. Many of our students are still having problem writing good equation and balancing the equations. So we are going to start it this way. What is chemical equation, or what are chemical equations? Chemical equations are signs, symbols and formula used to summarize the reactions that take place during an experiment, especially in chemistry laboratory. Signs, but if you look at the complete equation, there must be some signs. You have symbols of element and we have formula of compound that come together to complete an equation. So a complete equation is divided into two parts. We only have the reactant part and we have the product part. If you look at the symbol or the representation of an equation given on the board, A plus B equal to C plus D. The reactant part are the A and B that come together or react to give a particular result, which are the products C plus D. So we only have the reactant part in every equation. We have the product part. So we also have two major forms. Also we have different type of chemical equation, but two major forms that we normally have, especially at the elementary stage, for those who are just called the beginners who are learning chemistry afresh. We have equation which come as direct reaction between two chemical substances. Direct reaction between two chemical substances, and we have what we call decomposition reaction. The direct reaction is one in which two elements or an element and a compound come together, or two compounds come together to form a reaction. So let's look at some example of the direct reaction between two chemical substances. Direct reaction between two chemical substances. And before we go to that, I want our viewers to know that reaction are not just formed, or the product of a reaction are not just formed anyhow. A simple guide that will help everybody to understand this concept is that metallic part of the reaction of the equation will combine with the non-metallic part. Metallic part will take up the non-metallic part. Metallic part will take up the radicals or the ions. Are you getting it now? It take up the radicals or the ions. So let's look at the first example, in which hydrogen reaction, let's say reaction between hydrogen gas and oxygen gas. Let's see what this one will give us. When hydrogen gas react with oxygen gas, let's see what we are going to get. When students, you still make mistake writing hydrogen gas as ordinary H. No, anything you call the gas must have two under it. So as a molecule, it must exist as a molecule, not ordinary H. And oxygen gas in the same way, O2. If H2 combined with O2, normally we expect hydrogen to be acting as a metal here, but no, it's not really a metal in nature. So if you combine, take up the oxygen gas to give us H2O, which is what? Water, H2O. Since hydrogen and oxygen are present in that reaction. So the next thing after getting this, the next thing for us to look at the equation, if it is balanced or not. How do you know that? Hydrogen gas has two atoms. Hydrogen gas has two atoms on the other side, because the principle is that the number of atoms of each element at the right hand side must be equal to the number of atoms of the element at the left hand side. That is the principle of balancing an equation. But according to the order of the principle of conservation of matter or mass. Conservation of mass. So this has two atoms, this has two atoms. Oxygen has two atoms here, but it is having one here. So the next thing to do is to put two here, and the two you are putting in front of the water is representing both hydrogen and oxygen. As everybody should take note of that. So in that way, oxygen has become 4. 2 times 2 is 4, but oxygen still remains 2, because 2 times 1 will be 2 here. If oxygen is 4, then we have another challenge here. We have to make sure oxygen is also 4 here. So we put 2 here. So in that way, hydrogen is 4 here, hydrogen is 4, oxygen is 2, oxygen is 2, so it's balanced. Another example of direct reaction between two chemical species. Another example of direct reaction between chemical species is the reaction between magnesium and hydrochloric acid. Reaction between magnesium and hydrochloric acid. Hydrochloric acid. Hydrochloric acid. So magnesium is Mg. Hydrochloric acid, and sometimes you may need to put, not sometimes, every time you need to be putting the state of each of the substances. Here in the case of the first one, hydrogen is a gas, so always put the state. Oxygen is a gas. Water is a liquid. Magnesium is a solid because it's a metallic part of the element. Hydrochloric acid is aqueous. I told you in one of our previous classes that acid, bases, and salt are mainly aqueous in nature. They are aqueous in nature. So in that case, I told you by the principle of the principle I taught you the other time. The metal will take up non-metal. So you expect magnesium to take up chlorine, to combine with chlorine to give you magnesium chloride, not ordinary Cl, because someone will be thinking that you don't have 2 here. Why are we not putting 2 here? You have to come back to the correct formula of the compound you are forming in the product. So when magnesium combines with chlorine, it will not just be MgCl, but MgCl2. That is the formula, the right formula. Because magnesium belongs to group 2 of the periodic table, chlorine belongs to group 7, the group 2 have 2 valency of 2, chlorine have valency of 1. So when they exchange their valency, it becomes NgCl2, not just NgCl. Then hydrogen will be given up as a gas, plus hydrogen gas. So this is aqueous because it's a salt. It's aqueous, it's salt, and that the other one is a gas. So the next thing for us to look at it, if it is balanced or not balanced. Magnesium has 1 atom here. It is 1 atom here. Hydrogen is 1. Hydrogen is 2. So there's a challenge here. Chlorine is 2. Chlorine is 1. So the next thing for us to just put 2 here and see if that will balance the equation for us. So let's look at it again. Magnesium is still 1 atom. 1 atom. Chlorine is 2. Chlorine is 2, now 2, because when you write number in front of an element or a compound, that number is representing all the elements in that particular compound. So hydrogen is 2 now. Hydrogen is 2. Chlorine is 2. So it's balanced. It's balanced. It's balanced. So let's look at the other example before we end the class. So that is decomposition reaction. Decomposition reaction. Decomposition reaction. In this type of reaction, a bigger species break down under the action of heat or catalyst to give us smaller species. So an example is decomposition of calcium triosocarbonate 4. So in which CaCO3, that is calcium triosocarbonate 4, break down to give us, as I said before, metal take on non-metal. So calcium will take on one of the oxygen to give us calcium oxide plus CO2 gas. This is solid.